Hello there, this is Meth Affair, and today we're going to take a look at further examples on simplifying surds. Now, if you haven't seen my first video on simplifying surds, I recommend you take a look at that video, and then we can work through these further examples together. Now, the question we have here says, simplify and give answers in the form K root B. K root B. We want to give our answers in this particular format, where K and B are integers. So you want to make sure that when you're reading the question, you also pay or give good attention to the conditions of our constant. Our constants in this case are K and B, and the question says they must be integers. Remember, integers are positive or negative whole numbers. All right, so getting started with the first example, the square root of 98. So we want the magic breakdown, right? And I'm using the word magic here simply because we can, if it is possible, come up with two factors of 98, where one of them is a square number, the other one is a prime number. And in this case, it's possible. I am using the law of multiplication. So I am going to separate my 98 into 49 multiplied by 2. Then from there, I'm going to separate as well into single square roots or surds. So I have the square root of 49 separately multiplied by the square root of 2 separately. And then from here, we go ahead and we simplify. So simplifying this, the square root of 49 gives me a whole number 7. And the square root of 2 is a surd and cannot be simplified any further. So I keep it as root 2. Now you can see our solution is exactly in the required format, where the value of K there is a 7, and the value of B in this case is a 2. Our second example has an existing number outside or multiplying an existing integer, multiplying with our root. We are not going to do anything with the 2. We're just going to carry ahead our method and multiply the final result by 2. So taking a look at 288, and we can split or rewrite 288 as a product of 144 multiplied by 2. These are not the only numbers that multiply to give us 288, but remember, we are looking specifically for those numbers where one of them is a prime and the other one is a square number. And 144 is a square number, 2 is a prime number. We keep our integer 2 on the outside, and then we separate. This is the square root of 144 multiplied by the square root of 2. Simplifying further, we have the square root of 144 is simply a 12, the ordinary number 12. Root 2 is a surd, we keep it as root 2. Now we can multiply these two guys right here. And this returns a 24 multiplied by our root 2. And this is our final solution. So as you can see, starting up with a coefficient or starting up with a multiplier on the outside, an integer or a number multiplying with our surd does not interfere with our method. That whole number will eventually multiply with any whole numbers we get from our simplifying steps. Okay, taking a further look at more examples, we have the square root of 150. Now, there are some numbers where it is really not possible to have the magic combination, a square number and a prime number. Take, for instance, 150. Numbers that multiply to give us 150. We have 15 multiplied by 10. That's not our magic combination. We have 30 multiplied by 5. 5 is a prime number, but 30 is not. a square number. We have 25 multiplied by 6. Well, 25 is a square number and 6 is not a prime number. So sometimes it's not going to be possible to satisfy the magic combination. Nevertheless, that doesn't stop us from getting the work done. So take a look. We are going to go with the best of these, and I'm going to choose 25 multiplied by 6. So rewriting the square root of 150, we have it as the square root of 25 multiplied by 6. I could have gone with any other products of 150, any other two factors of 150, but I chose 25 multiplied by 6 because at least we have satisfied half, right? We have satisfied half of our magic combination. 25 is a square number, though 6 is not a prime number. All right, so proceeding to separate these using the law of multiplication, I have the square root of 25 separately and the square root of 6 separately. Then we simplify. The square root of 25 returns a whole number, 5. The square root of 6 is just going to remain the square root of 6. So yet again, we have our answer in the form k multiplied by root b. So it's not going to be every time that the value of b is going to be a prime number. There's no need for us to, further break down 6, because 6, can only be rewritten as 2 multiplied by 3, and both of these are prime numbers, so their roots are still going to remain as root 2 and root 3, so we'd rather have it as a single root as root 6. Okay. My final example is root 35. Now, the square root of 35, if you think about your times table very quickly, the numbers that multiply to give us 35. I can only think of 7 multiplied by 5. We are not going to talk about 35 times 1 because that leaves us in the same place with the 35. All right, so if I separate or if I rewrite my 35 as 7 times 5 and separate this into a root 7 multiplied by a root 5, none of these are going to simplify further to give us an integer solution or an integer, value. The square root of 7, it doesn't simplify. It's a third. Root 5 is also a third. So there are numbers like these where it is actually impossible to simplify them into an integer and a root. So this cannot be written in the form k root b. But instead, we were able to write it in the form square root of k, maybe multiplied by square root of b. So in such instances, we may be asked instead to write or to break down our third into 2 thirds. And this is a special case with the square root of 35. All right, so this is simplifying surds. Watch out for more videos on surds. See you next time.